Okay, so this is lesson 6.5, which focuses on the language of comparison problems. We're going to look at two different kinds of comparison problems, additive and multiplicative. And we're going to really focus on the different language in these types of problems and some of the diagrams that we can use to help us. So it's important to note that sometimes in a word problem, you're dealing with what's called leading language, and sometimes you're dealing with misleading language, okay? So here's an example of two problems that are both additive in nature, but one has leading information and one has misleading information. So if I have the first problem, altogether the blue team jumped 11,485 times. The red team did, how about jumped, 827 more times than the blue team. How many jumps did the red team do? That's called leading information because it uses the words more jumps than, and it leads you to know that to solve this problem, you're going to do 11,485 plus 827 to get your answer. And so it led you to this. Whereas in this other problem, you have misleading information. Ted jumped 1,300 times. He did 100 more jumps than Mario. How many jumps did Mario do? Now, if that were leading information, it would just be simply 1,300 plus 100. But that's not how you would figure out what Mario did. In fact, Mario jumped less. So if I add that, it would be completely unreasonable. So that wouldn't work. To solve that problem, I'm actually going to subtract because Ted jumped more. So to figure out Mario, I have to subtract. So it would actually be 1,300 minus 100. So that's an example of misleading language. It uses the word more than, which would indicate to a lot of people that you need to add. But when we're examining a problem, we can't just pick out words. We have to look at those words within the context of the problem. So this is an example of leading, and this is an example of misleading. So I really want you to write these two down. So I'm going to pause and do that now. Now, here's another example of leading and misleading information, but this time it's multiplicative. So in my first example, it says Maria scored 6 points in the basketball game. Suzanne scored 4 times as many as Maria. So how many points did Suzanne score? So that's going to just be 6 times 4, because that's idea of 4 times as many, right? Equals, and I would figure out S, or how much Suzanne scored. That's leading information. The phrase 4 times is what you do to solve it. Now if you look at the other one, Mr. Wagner has 32 horses on his farm. He has 4 times as many horses as Mr. Cruz. How many horses does Mr. Cruz have? Now if I stop and think, I have Mr. Wagner, who has the most. He has 4 times as many as Mr. Cruz. But if I don't do that, if I just look and see 4 times, I'm going to look at my numbers. 32, 4 times. So 32 times 4 should equal Cruz. But that's actually incorrect. If I look at it, it says Mr. Wagner has 32 horses. That is 4 times as many as Mr. Cruz. So it's actually Mr. Cruz times 4 equals 32. So then to solve that, I'm not actually going to use multiplication. I'm going to solve it this way. So that's an example of misleading language in a problem. So pause and write those down now. Similarly to last week, there are different problem types. We're going to go through 3 that are additive comparison problems and 3 that are multiplicative comparison problems. And we're going to solve them, and we're going to use diagrams to help us do it. And I really want you to write each of these down and draw each of the comparison diagrams. We're going to reach back to what you learned about comparison bars, hopefully in earlier grades. And so if I look at my first type of additive comparison, that's when I'm comparing and the difference between the two values is what's unknown. So here's an example. Julia jumped rope 1,200 times. Samantha jumped 1,100 times. How many more jumps did Julia do? So Carson's in first grade, and they just learned about comparison bars, so I'm sure you learned this at some point. It may have been in first grade or a different grade level, but I'm going to reach back to that because I really found that these diagrams are super powerful to help you visualize the problem. One of the things Carson learned in his class was that you have basically two rows. So you draw two bars, one that's just a little bit longer than the other, and the longer bar always goes on the top, and then you have a circle to show kind of the difference. So if I look at this, it says Julia jumped roped 1,200 times, Samantha jumped 1,100 times. So I always think first, who jumped more? And in this case, that's Julia. So I'm going to label that bar as J for Julia. And who jumped less? Samantha. So S for Samantha. Now, I'm going to fill in the information I know. Do I know how much Julia jumped? Yes, I do. I know she jumped 1,200 times. Do I know how much Samantha jumped? Yes, I do. She jumped 1,100 times. Do I know how many more? Nope, that's what I'm finding. I'm finding the difference. So to solve that would be, I could look at the situation equation, which would be 1,100 plus, we'll say more, I guess, M for more, equals 1,200. I'm sorry, I have a really sore throat tonight. And then I would solve that by doing the exact opposite, which would be so my answer would actually be, Samantha jumped 100 less, or Julia jumped 100 more. So that's the diagram for that. Sometimes we solve problems where the comparison and we know the greater value, we know the lesser value and the comparison, but we don't know the greater value. So again, I would draw it the exact same way. Greater bar on top, less bar on the bottom, comparison in the circle. So altogether, the blue team jumped, 11,485 times. The red team did 827 more times. Interesting. So red is actually greater. So I'm going to put red on top, blue on the bottom. I know blue jumped 11,485 times. I know that this is my comparison language, so I'm going to put that in here. And the question asks me how many times did the red team jump, or how many jumps did they do. So that's what I'm trying to find. So I know that if I do 11,485 plus 827, I will get my answer. So this is 12, 10, 11, 13, and so, I can't get that to right. So R equals, or the red team jumped 12,312 times. So this is an example of where the difference, or what goes in the circle, is what's unknown. And this is an example of where the greater value is unknown. I bet you can guess what the next one is. It's that the lesser value is unknown. So before I even read the problem, I can set up my diagram, because you always draw it the same way. That's a really bad example because my circle shouldn't go past my rectangle, but we'll go with it. Ted jumped 1,300 times. He did 100 more, that should say jumps than Mario. How many jumps did Mario do? Well, who was more? Ted. Who was less? Mario. Now, which numbers do I know? I know Ted jumped 1,300 times. I know he did 100 more. So that's the comparison words or the difference words. But I want to find out Mario. So I know that I can do 1,300 minus 100 to get my answer, which will be 1,200 jumps. So that's an example of where the lesser value is unknown. Okay, so now let's look at comparison problems that are all multiplicative. So, excuse me, multiplicative diagrams look a little different. I hope you learned these in another grade level. If not, when you come in tomorrow, I need you to tell me so that we can review them. So the first one is when we compare, but we don't know the product. Okay, so remember last week we talked about sometimes we multiply and we don't know the product. Sometimes we have multiplication problems or division problems where we don't know the number of groups, and sometimes we multiply where we don't know the size of those groups. So this first one is that we know both the number of groups and the size of the groups, but we just need to find the product. These are those basic multiplication problems. So the length of an unstretched spring is 120 centimeters. How long, or L, will the spring be if it is stretched 3 times that length? So a multiplicative comparison is sometimes just called a bar diagram or a strip diagram or a tape diagram, depending on what book you're using. And it looks like this. So I have 2 different types of spring in this case. I have the unstretched spring and the stretched spring. The unstretched spring is 120 centimeters. Okay? The stretched spring is exactly 3 times that length. So I essentially drew this rectangle 3 times. Okay, I made it a strip of them. So we know that there's 3 of them. And I want to know then, how long is this? So basically, I know that if I do 120 times 3, because this would be 120, this would be 120, and this would be 120, I'll figure out how much the total length is. So my answer would be 360 centimeters long. Okay, so that's an example where I was finding the total or the product of the number of groups and size of groups. Okay, now this next one is a bit different. We're comparing, but we know the product already. We just don't know how big the groups are. So the length of a collapsed fishing pole is 1/8 as long as its extended length. So I've got 2 sizes. I have the collapsed and the extended. I know that the extended is going to be 8 times as long because 1/8 of is the same thing as 8 times. So what I'm going to do is I'm going to take this bar, I'm going to break it into 8 pieces. And I'm going to make the collapsed one just one of them. Okay. So do you see how this shows this is 1/8 of this? So this here times 8 would equal that. Sorry, I can't get it to undo now. Go back. There we go. The extended pole is 16 feet. So if I look at this whole thing, this is all 16. So if the whole thing is 16, I'm essentially breaking the 16 into 8 pieces. So if I did 16 divided by 8, that would equal 2. So this is 2. And I can prove that because 2 plus 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 2 equals 16. Pause, write that all down before you go to the next one. Now our last one is when we're comparing and the number of groups is unknown. So it's similar, sort of. A maple tree is in the backyard and it has a height of, 0.75 or 75 hundredths of a meter. How many times tall is a nearby hickory tree that's 9 meters tall? So if I have, excuse me, I have 2 trees. I have my hickory tree, which I know is 9 meters. And I have my maple tree, which is, I'm not going to be able to fit it inside, so 0 and 75 hundredths meters. I want to know how many times bigger this one is. So it's almost like my situation equation might be 0 and 75 hundredths meters times, we'll say, h for height equals 9 meters. To solve that, get myself some more space. To solve that, I would have 0 and 75 hundredths divided by 9. So because I want to know how many maple trees does it take to be as tall as the hickory tree. So I have to get that decimal out. 1, 2, 1, 2. 75 goes into 90 one time. I would have a remainder of 15. Bring down the 0, and that's exactly perfect. So the hickory tree is 12 times as tall as the maple tree. Ooh, bad spelling. So I guess what I really want you to get out of this lesson is that the language matters, and digging into what the problem's really telling you and what the problem's really asking you is what helps you to figure out how to solve it. Drawing those diagrams for me helps me visualize what it's telling me and what I'm looking for, so that helps me to figure out how to solve it. One more thing that's important to note that I didn't make a slide for, so I'm going to add on this next page, is, like I said, we have these 2 types. We have additive comparisons, and we have multiplicative. Multiplicative comparisons. And with additive comparisons, to solve them, I'm using addition or subtraction. I think it's misleading for me to just talk about additive and not tell you that you have to use the inverse operation sometimes, depending on which information you're looking for. And then the same is true for multiplicative. I feel like, again, that's misleading. That makes you think you're only multiplying, but sometimes you'll multiply and sometimes you will divide. And that's depending on what information you're looking for. So it's important that you pause or go back or rewind as many times as you need to make sure that you write down all of these different problem types and the examples and the diagrams that go with them. I truly believe that those help you when you're problem solving in the future. You'll be able to read a problem and say, oh, well, this is a compare, but the number of groups is unknown, so I'm going to divide to figure it out. So I feel like that information is very important, so I want you to make sure you have all of that in your notes before tomorrow. And